My first question is whether a line that passes through 8 lattice points in this cube of lattice points, can that line pass through two opposite faces of this cube? In three-dimensional space, we can represent a line parametrically. We're interested in the points on the line between 1, 1, 1 and 10, 10, 10. For example, let's consider the line that passes through a corner of the cube. Since we're interested in lattice points where the coordinates are integers, let's make our parameterization add 1, 1, 1 to each of the coordinates. And let's find the lattice points that the line passes through that are inside of this cube. When t is 0, our line passes through point 1, 1, 1. When t is 1, it passes through 2, 2, 2. The last lattice point that our line passes through is 10, 10, 10 before it leaves the cube. This gives us 10 lattice points, which is too many. To get fewer lattice points, let's change our parameterization. We'll start at 1, 1, 1 again. And again, since we're interested in integer points, we'll just change the z-coordinate of this parameterization to 2. And let's see what our lattice points are. We start at 1, 1, 1. When t equals 1, we add 1 to our x and y coordinates and 2 to our z coordinate, and we keep doing that. When t equals 5, the lattice point is 6, 6, 11, and we've left the cube, so it doesn't count. This leaves us with only 5 lattice points, which is less than what we want. Any other parameterization with integers is going to skip too many lattice points. So we can't skip any lattice points in any of the x, y, and z directions. This means that any line that intersects 8 lattice points will not exit the cube on opposite faces. This means our line is going to exit the cube between faces which are adjacent, that share an edge. One technique for dealing with 3 dimensions is to find the projection onto a plane. We can count our lines by counting their projections. We're going to consider projections of our lines that pass through 8 lattice points onto the xy plane. That means whatever the z-coordinate of the lattice point is, we will replace that with z equals 0. Let's say these 8 dots are the projection of the 8 lattice points of the line that passes through the cube onto the xy plane. If point A is here on the left, it has x-coordinate 1, y-coordinate 6, and some z-coordinate. B is at 8 and 6, and its own z-coordinate. The line passing through A and B emerges from the cube at one of the top or the bottom faces at B. This means the z-coordinate of B is either 1 or 10. That's where the line emerges from the top or the bottom face. To get 8 lattice points, we subtract 7 from the z-coordinate of point B. We can also add 7 lattice points to the z-coordinate of point B. So for example, let's start with the line passing through the point A, where A is 1, 6, 3. As it passes through the cube, the next lattice point is 2, 6, 4, and then 3, 6, 5, and so on to our last lattice point, 8, 6, 10, before it emerges from the top face of our cube and leaves the cube. We can also descend from A to B, where A is at 1, 6, 8. The next lattice point is 2, 6, 7, and so on, until it exits from the bottom face at 8, 6, 1. We see that we have 2 segments for this projection, segments that pass through 8 lattice points. There are 10 similar projections along this side of our square, with 4 sides of our square. That gives us a total of 80 segments. Let's see what happens when our projections are diagonal. Here's a projection of a line passing through a cube that appears as a diagonal on the xy plane. Point C has x coordinates 1 and 1. Point D has x and y coordinates 8 and 8. Point D is where the line leaves the cube through either the top or the bottom face. That means the z-coordinate of D is either 1 or 10. If the z-coordinate of point D is 1, then the z-coordinate of point C, we add 7 additional lattice points to it, and it's 8. If the z-coordinate of point D is 10, then we subtract 7 additional lattice points, and C is at z equals 3. So for example, we can start with C at 1, 1, 3, and then ascend 2, 2, 4, and so on, until we get to point D at 8, 8, 10. Or we can descend from point C at z equals 8 down to z equals 1. That's 2 segments per projection. These are projections that are coming from the 4 corners for a total of 8 segments. Let's look for some more diagonals. Let's consider the diagonal projections just above and below y equals x. We'll call this point E and this point F. E is at 2, 1, and its z-coordinate. F is at 9, 8, and its z-coordinate. The z-coordinate of point F can be either 1 or 10. If it's 1, then the z-coordinate of E is 8. If it's 10, then the z-coordinate of E is 3. That's 2 segments producing this projection. We have 2 projections for each corner of our square. This gives us a total of 16 segments. Let's go to the next diagonals. Let's look at projections that are 2 above and below each of the diagonals. We'll call these points P and Q. P is at 3, 1, and its z-coordinate. Q is at 10, 8, and its z-coordinate. We have a lot more options now for the z-coordinates of P and Q. Let's consider first the number of segments where the z-coordinates of P and Q are the same. These z-coordinates can be anything from 1 to 10, so that gives us 10 segments per projection. If the z-coordinate of P is less than the z-coordinate of Q, so we're ascending from P to Q, we need to add 7 lattice points to our z-coordinate for P. When the z-coordinate of our point P is at 4, Q has a z-coordinate of 11, which is beyond the scope of our cube. Here we have 3 ascending segments for this projection. So for example, this first one here, P has coordinates 3, 1, 1, and leaves the cube at coordinates 10, 8, 8. With the symmetry of these projections, if our line descends from P to Q, we get another 3 segments for this projection. That's a total of 16 segments for this projection, and we count 4 such projections for a total of 64 segments that pass through 8 lattice points. Now we can count up all our segments. We have 80 over here, and another 8, 16, and 64. Our total is 168. If you'd like me to solve any other AMC or AIME problems, please leave them in the comments.